Hi guys. Okay, so in this video, I'm going to cover chapter 4 and chapter 9 exercise problems. Okay, so both of these chapters, they connect well. So we are going to look at the chapter 4 problems first. So here, 4.8.3, how many protons, neutrons, and electrons are present in a given example? Now, some of the exercise problems have several subparts to it. So I'm just going to do only one or two part, depending upon, which ones are like a little bit more difficult. And the second thing is that you should be doing the practice also. So I'm just showing you, some methods how to do them. All right. So here we have, as you can see, this number is the atomic number. This number 27 is the atomic number. And atomic number defines the identity of the atoms. And this number here is the mass number. So the mass number is the number of protons plus the number of neutrons. Atomic number is the number of protons, and this is also equal to the number of electrons. So here we have the answer that the number of protons is equal to 27. The number of electrons is also equal to 27. And now comes the number of neutrons. So that we will have to take the mass number, which is 60 minus 27. So 60 minus 27, 60 minus 27. That is a mass number minus the atomic number. And then that is going to give you the number of neutrons. So 3, and here's 5 minus 2 is 3. So 33, okay? So 33 is the number of neutrons. And that gives you the number of neutrons this way. Next is, the next question is finding the abundance, okay? So abundance is basically finding the average mass of the isotopes. So just give me 1 minute here. Okay, so the next question relates to isotopes. And isotopes are those substances that have the same number of protons, but different number of neutrons. So these isotopes are, they only differ in the mass numbers, but their atomic number is the same. So here you have chlorine, and the thing that is not written in the book is this should be chlorine 17, and this is chlorine 17. So that's the number of protons and the number of electrons. That's not changing. The only thing that's changing is the mass. And the mass given is, in the first case, is the 35, and the second is 37. Now, 35, chlorine 35 is found in more abundance. And that abundance is 75.77. Chlorine 37 is in lesser abundance and in comparison, and that is 24.23. So that's 37. So it's comparatively rare. So, but they have identified the mass, the more masses, so 35 and 37 are just, rounded up numbers, but the real mass is this. So how do you get that? So you multiply that. You're going to find the average isotopic mass, average isotopic mass. Okay, average isotopic mass that is recorded in the periodic table. Okay, so but when we are doing the calculations, then fine, we can just do the rounded up numbers, but in the periodic table you will see the average of the isotopic mass. So how do they calculate? So you multiply the abundance by the mass, and that gives you the average isotopic masses, but you have to add them also. So here you're going to take this 75. So here it is, the 75.77 divide by 100 times 34.97. Okay, so this number is 26.49. Okay, now where you should stop here, although it's a big 4967, so do not round up at this stage. So I'm going to just write down the full number here, 26.49, and then that is the 6, 7, 269. That's on the calculator. But you are only going to keep the 2649. Why? Because 4 significant figures, 4 significant figures. So when you multiply, you will have, so these are 4 significant figures. This is 4 significant figures. So multiplication, we look at the lowest significant figure. So here we only have 4. So we are just going to keep this. So this gives you 4 significant figures and the rest are dropped. Okay. All right. Let's look at the next one. 24.23 times 36.97, 36.97, divide that by 100. And here you get 8.95. So 8.9579. Oh, something happened here. Lost touch. Okay. 8.9557.831. So this is the number I get from the calculator. So here you see 4 significant figures. Here you see 4 significant figures. So here also we would need 1, 2, 3, 4, and we are going to drop off the rest. So 4 significant figures we can get, right? So in other words, here, do not round up. Do not round up at this stage. Okay, just leave it as it is. All right. So now you're going to add these numbers. Okay. So now when you are doing the addition, so let me just put this in a separate. So here, so when we add and subtract, I'll put this later. So here, when we add and subtract, so when we add and when we subtract, so what do? We look at the lowest decimal point. So lowest decimal point for the final answer. Okay. So here we'll see now how many points are there. How many decimal places are there? So we have 2 decimal places, 2 decimal places. And here we have how many? 3 decimal places. Okay, so I should have used another color. Give me 1 second. So let me use a different color here. So this is 2 decimal places. And this is 3 decimal places. So your final answer should have only 2 decimal places. Okay, so here's the rule: do not round up in between steps. Okay. All right. So now we are going to just add these numbers. So add them. So we are going to add 26.49. All right, add that to 8.957. Okay, and you get 35. We get here 35.447. Okay, this is what we get. But the final answer should only have 2 decimal places. So what do? We're going to drop 7. Okay, but 7 is more than 5. Therefore, 4, we add 1 more, and that becomes 5. So this is going to round up. So now your final answer is 35.45 atomic mass units. So that's the mass of chlorine that you see in the periodic table. And because chlorine 35 is more common, more abundant in nature. But anyway, so this chlorine 17 and that, 35. So we use 35 atomic mass unit or grams per mole later on, you will see. But that's how you do these calculations. But keep this in mind that there is going to be a question on the test on isotopic masses. So pay attention to this. Average does not mean divide by 2. You see, the method is different. This is just simple addition. And remember all these, there is applications of the rules regarding the significant figures. So that's one piece. Now we are going to look at chapter 9. Okay, chapter 9 is about atomic structure, electronic configuration, and a very interesting chapter. So here, what do you see? Or actually, I'm thinking I'm going to do the chapter 9 in the next video. So it's just so you can keep the focus that way. Otherwise, this one is going to become very long. Okay, so chapter 9, next video. Okay, all right. Thank you. Thank you for watching.